Let's continue with our next section. Let's talk about how do we treat missing data. Now, missing data is whenever we have null data, um, all those other things. And that's kind of a really important thing. But the problem is there is no universally accepted method to do it because sometimes we do is called imputing, which means we replace the missing data with something else, usually the mean, median, or mode. Um, we, there's a whole bunch of these. You also notice down here, other methods includes KSN, that's the K nearest neighbors, SMOTE. I've used that one before. Other deep learning where we're kind of trying to replace it. We can also use some strategies where we simply ignore it and it doesn't matter. We can drop it. I have had situations where I looked at it, I'm like, I have like 600,000 things and I have one row that's missing data. I'm just going to throw out that one row. And so you kind of have to make this decision, and it's not always a perfect science. It's something you kind of have to play with. So what we're going to do is we're going to talk about some different examples of that, and we're going to also look at how those things can affect. Because if you impute things, let's say with a mean, then the outliers of that column are going to start polling. So that may not be the best thing. Also, there's times when I might be missing a whole bunch of values, and that really will affect. So the percentage of missing values might be the key thing. So first off, let's come down here, and we're gonna again remember what I'm doing right here is I'm gonna do PD data frames. I'm gonna actually create a whole new data frame, and I'm gonna do the count of when it is null. So it's gonna go through, and it's gonna this first portion, it's gonna count up when it's null as long as, and then it's gonna return it as long as the null is bigger than zero. So it's gonna do a count and say, okay, as long as there's any null values, I'm gonna include this column. And then once it does that, it's actually going to then compute this by taking that sum divided by the total number of rows, which is in other words going to give me the percentage. So this is going to create a whole new data frame where I can see the percent of missing data as well as the count. So just to illustrate this again, this first column, we get to see count. The distance is missing one value, postal code is missing a value, and that's 0.4%. Not very much. Whereas bedroom and bathroom are missing pretty much the same values, both about 23%. Car is also 25%. But come down here, we have really, really big values in that we have the building area. 61% of the data is missing it. Year built, 55%. Those are huge numbers. So let's first do a little bit of exploration of this because we have some numbers that are pretty close. I mean, like total space, car, and that should make sense because we calculate total space based on rooms, bedrooms, bathrooms, and cars. So that number should be there. But let's look at this a little better because there might be some correlation. So let's first come and let's just start with the first thing, distance. There's only one value. So let's pull that up and say, what is that one row that is missing distance? Can I look at it and get some more information? And this is kind of a critical idea, is that I want to understand what's going on with a singular row because that potentially could have more impact. Now, that one row, we'll notice it's in Faulkner lot, has 3 bedrooms, it's a house, sold by Brad, 2018 was sold. Distance missing, postal code missing, bedrooms missing, bathrooms missing, cars missing, land size missing. Whoa, there's a whole lot missing here. So now we're missing a ton of information. So this one row is missing a lot of stuff. If it was just missing the distance, but had, you know, the bathrooms, the car size, the postal code, all those other things. So we now have a lot. So let's actually come down. Let's say, okay, show me all the things that are in that suburb. So I might as well just before we just completely throw it out. I mean, that doesn't seem weird, but let's look at just the suburb because maybe there's other things in the suburb that have similar issues or something else. So I pull up the rest of the suburb and there's only one number. So because there's only one data spot in this suburb, that kind of means that I really don't have anything known that I could impute. So imputing would be not really intelligent right now because I'd have to be dropping, I mean, I have to be pulling information from a different suburb. I don't know how it compares in terms of the size of the house. There's nothing to compare it to other than, well, I know its price was 616,000. Okay, that doesn't really help me. So this is not just some random. There is a reason this is missing. Maybe this is just a flaw. Maybe this is an empty lot. I don't know. Um, but for the sake of, if I was going to do any data science, because again, if we're trying to do like a model on this, missing data is going to mess with our stuff. So we're actually going to need to come along and let's go ahead and drop it. And again, I'm gonna do a couple things. I'm going to tell it to drop. And now notice I actually told it the row number, 9590. And then I told it to reset the index and drop equals true because we want it to not just have that and have our index is incorrect. We actually want to reset them and also have the correct one. So I now have created it. Now, if I come back and hit and create my list again of the count and percentage of missing data, notice we've already lost distance and postal code are gone. Distance bin is obviously gone if distance is gone, but it's affected a lot of stuff because that one had a lot of things. So we're now down to a lot fewer, just 8 different categories. So let's look at a little more. So let's come to this next one, bedroom. When is bedroom null? Now, if I click this, you'll notice I have a bunch of dots. So it starts in row 8, 12, 14, and then it jumps. So it's only showing me again the first 5 and the last 5 for which this is true. But I'm doing this to look for a pattern. Again, is there a pattern I can see here? Well, as I'm looking through here, I see a bunch of different suburbs. Number of rooms seems to be bouncing around. I see houses and some units, different sellers, lots of different dates. Distances are varying. Postal codes kind of are categorical. But wait, when bedrooms are missing, notice bathrooms, cars, land size, building area, year built, at least in all the ones I can see are missing. That doesn't mean that all of them are that case, but it means a whole lot of them. And then obviously total space is missing because, well, if you're missing those and we calculate the total space. So that makes sense why total space would be. But the fact that the bedrooms and bathrooms, if bedrooms missing, bathrooms is missing, that seems important. So let's look at the situations where if the bedroom is null, I want to look at the bathroom. So in other words, I want to count, and this is going to count up because I'm gonna do value counts of null. Now, if I don't do drop NA equals null, it will just ignore the nulls. It's just what it does. By doing that, I'm actually telling it to not drop them, and to give me this. So this is actually going to give me the value counts of different categories. And it turns out that everything in, so in other words, I'm saying, show me how many of the different bathrooms there are when bedroom is null. What are the different values? And all of them are null. Okay, so that tells us right there that if bedroom is null, the bathroom is also null. Okay, what about if bedroom is null? What about what's car look like? Because remember, we saw a bunch of cars. Oh, they're also null. Okay, so we have a double overlap. So if bedroom's null, then bathroom's null and car's null. Now we're starting to see a pattern. What about land size? That was another one that we had a correlation. And we'll see here quickly that while most of them are, there is a couple that don't quite fit that. But so there's a few where we have a land size, but we're missing other stuff. And so this very well could be like these could be empty lots, because these could be lots very well if I wanted to really dig into this data. Just these 6 right here would kind of be something where I'd be like, I don't have anything else. And I might want to look at those 6 and get some more information. But for the sake of this, we're just going to make it simplistic. I want to demonstrate some different strategies. We continue on. Let's look at building area, all null if the bedroom's null, and year built, all null. So excluding land size. All the other characteristics are null if the bedroom is null. And even the land size is almost completely that way. So this means there's a strong pattern that if bedroom is missing, all the other columns are also missing. Okay, so let's look at some patterns based on suburbs and regions. In other words, we're going to see if we can break it down. Because if we start imputing and we want to impute on the whole data set, it's really hard. Because we already showed earlier when we were doing bivariate analysis, for instance, we saw that price was related to number of bedrooms. And we also saw going back that it was based on where it was located. So what we're going to do is let's look up, let's see if there's a pattern. Is there a specific suburb? This is going to look at, is there a suburb that when bedroom is null is going to have more? And we look at this and they're actually all over. It's not like, in fact, quick thing, it says there are 307 different suburbs that had missing nulls. And again, if I just looked at the total number of suburbs, that's the N unique, there's 344. That means I have all but 37 of my suburbs. So about almost 90% of my suburbs are missing have at least one of these missing bedrooms built into them. And a number of them have clearly, you can see the top, the reservoir down through like Richmond. I mean, you're talking hundreds, and that's a lot of information. So we have a lot of, and we can't like, oh, this suburb is missing all of them. These suburbs have all of them. That doesn't really quite work because again, we don't know how many there are in Plenty or Scoresby. There could be only like 2. And so that could be a huge skew in the data there. Well, let's look at region. Again, it's skewed more towards the metropolitan, but remember, there are way more in the metropolitan. So that doesn't seem to make sense. Again, there's no pattern. But if there's no pattern, that means that we can impute that this is almost like random across the whole thing. So we can kind of say, okay, there doesn't seem to be a pattern or connection, which means these two things seem to be a little bit just general. So one of the things we're going to do is we're going to treat the missing values based on the region and the type of the home. Because think about it for a second. The number of bedrooms, remember we looked at like bedrooms when they're the outlier bedrooms that are over 7. And we found that those only occurred in houses and a couple of apartments. So if we break this down, region, and I want to know what is the mean value based on region and type of home, what's the mean value? So I'm using this group by function. So that means I'm going to first group by these things. So it's going to go through and look at region, and then within region, it's going to look at type, and then it will break down for these things, it will take the mean. So it'll take the mean of bedrooms, mean of bathrooms, mean of cars. So running that, again, it's going to give me this really nice table, and this is great to look at because now we can start seeing when we break down by region that we can clearly see the number of cars, and it does fluctuate even by like house versus unit. And that would make sense. Most apartments don't necessarily have a car or they have one car spot. Some have 2, obviously, but there's a lot more variance. Bathrooms are going to vary. So, but also even between different places. So Northern Metropolitan has a 3.106 mean versus Eastern Metropolitan's a 3.55. And all the way down here, you can even see 3.244 for Western Metropolitan and so forth. Now, interesting note here, Western Victoria only has houses. There's not even any townhomes or units in that whole area. And that's true that some of these, like Eastern Victoria, has the same thing. The Victorians apparently don't have any townhomes in them. And there's probably, it looks like, I mean, the fact that this is perfect integer all the way across leads me to believe there's probably only a couple, possibly one. And that's why. So units are even rare in there. So we're going to look this. Now, I'm going to want to take these and want to fill them in. I have a couple different options. I can literally copy these down and be like, type. And that would be so annoying. Instead, I'm going to use what's called the transform function and the fill NA function. So the fill in a function, you tell it a column and you say fill in a. That means it's going to take all the null values. I'm going to fill it with value X. It literally is going to just do that and it's going to fill it. And then I'm going to use this transform because it's going to take something like this. It'll take this data frame up here, pardon me, and it actually can transform it and extract the data out of this thing right here. So I'm going to use this for bedrooms. So we're going to take data bedrooms. So this is, and I'm going to replace it with data bedrooms where I'm filling the null value where the value, so that means the value is going to be, and now notice this right here, if it was dot mean, would be our table that we just had up here, except it did transform mean, which means I want to, when it pulls up a bedroom, it's going to look at group type, and it's going to look at the mean of the bedrooms in that region based on region and type and so forth, just like we had up here. So if it's going through and finds a bedroom, it's going to, in Eastern Metropolis, it's a home, it's going to put 3.552. That's what this is going to do. So this is going to impute that. I could change this if I wanted to make this median. It would do the same exact idea, except to replace it with a median value. Let me go back and keep this all mean. So again, you got to figure out which one you want to replace it with. We can do the same thing with bathroom, with car. So we've now replaced all of those with the missing data that we just found up with the mean. So we're kind of taking the average. I mean, that would make sense that, well, I don't know exactly, so let's just go with the average. Again, if it kind of depends on a lot of things. And a general strategy someone told me one time is if you're honestly dealing with less than 5% of your data, and I'm talking like large data sets. And really, if you're under 1%, just throw the data out, throw out the missing values. It doesn't really affect your overall subset. If I'm dealing with, over 10,000 data points, throwing out 100 does not even make me blink. On the other hand, because I mean, I just did a data set that had, let's see, what was it? It's over 1 million, and there were like 5 that were problematic. So I threw out those 5. Um, didn't like them. I was like, I'm not going to do a fitting. These don't really fit into my model anyways. But you have to be careful because if you throw out valuable information, that's also bad. So because there are extremes, so we have to kind of figure out what's going on here and so forth. That was a survey data where 5 people didn't answer information, and there's millions, and that was a different situation. All right. So now let's come back and let's look at what data is still missing. Well, notice we've now taken care of bedroom, bathroom, and car. They're gone. Total space is still here. Why is total space still here? Well, this is one that we created. And so we can actually take care of this. Now, there's another thing that's slightly problematic. While we got rid of bedroom, bathroom, and car, we replaced them with the mean, which means now if I look up some places in Eastern Metropolitan, they're going to have 3.55 as the number of bedrooms. That doesn't make any sense. Or 1.946 cars. That doesn't make any sense. Now, what we're going to do is we're going to change them to all of them to being integers. This is a floor function. It doesn't say it, but when you do as type, because I want to change them into that, it's going to, because I actually want all the data to be integers anyways, it doesn't make sense to have non-integer values for bedrooms and car. I guess you could have a 1.5 car garage. I don't know. But in general, let's say integers for the sake of this thing. This is going to round down all the values. So the interesting part, let's say that a home in Eastern Metropolitan, it was missing car value. It got 1.946. It's going to round, the floor function takes that all the way down to 1. So this is downside of the floor function is it's always going to round down. If I wanted instead to change that into something like, say, a I just lost the name. If you want to round, just round it to the nearest integer based on our normal rounding. You can also you can do that and then change that into integers. Because if you just do a rounding, it's going to first turn it into still be a float, and then we'd have to change that back in integer. All right, now again, remember total space. The problem with total space is we'd already calculated it before we imputed all these values. So we need to recalculate it. So first, let's drop our current one, or drop that column. There's no sense. And we're create a new one that's really the same thing, and we're going to label, make sure it is an integer. And just to check it out, let's just gonna give another one. Let's do data dot head. So now I have a new column called total space. And we can quickly see that 9 is 1 plus 2 plus 3 plus the 3 bedrooms that are over 3 rooms that are over here. So it is working out. It's all looking great. So we've now created our new column. It's looking wonderful and great. Now we do want to take a minute and look at our relationship. We want to make sure, remember earlier, when we looked at the bivariate analysis between total space and price, we saw a relationship. When we look at it again, we have a similar relationship. This is the one we tried doing the line of best fit. And I mentioned that this outlier over here is messing with it. It's still messing with it, but we now have to take that into account, that it's going to have the same general relationship. That's good. If you impute things and now the relationship changed, so like this is currently upward, kind of a positive slope. If I did a line of best fit, if I changed it and suddenly it's flat or it's a negative slope, that's a major problem. So we just don't want to change our relationship. We want to kind of maintain things and just kind of, we can use it. Let's talk about land size for a second. Let's come back and let's look at the missing land size. So notice land size has this huge spike here. I don't know, that's really small. And then it trickles out. So this is extremely skewed. And so if I impute this with mean, these outliers over here are going to, I mentioned outliers really dramatically mess with stuff. These are really going to mess with it because you could have something that's in here that's like land size of 500 or 1,000 or 5,000. And this 80,000 or 70,000 over here is going to really mess with that. And so instead, let's look at it by median, because remember, medians can take the middle value, so it's going to be more around here. That'll be more realistic for my missing data. Now, there's way more things. Again, I could be like, well, land size would also be based on partly on distance. So how far out are they from the home? There's a lot of other things. And now I have all this. So I can again do the same transform function, except I can do it on the median because that's better. And now if I do that again, notice all that's left is building area, year built, and age of the property. So these things are kind of where we're going to kind of step up next is what can we do? Well, I still have a whole bunch. Now, a couple things to point out. I'm still missing a lot of this data. I'm still missing 61% of the building area. That's huge. So I'm missing more than half the data, which means if I try doing imputing, I'm essentially going to create more than half my data. That doesn't sound like it's a good idea. So because of that, I would not impute. There's a couple different things here. We could delete all these rows. We could ignore them, or we could just drop these columns so we don't use them when we do some kind of analysis. So again, I'm just going to create a new data, and this is literally going to say a new data frame where it's going to have everything except building area. And now I'm missing, so I'm only going to take the ones that have building area that are left. And you'll notice my indexes already, I'm missing some right here at 2 and so forth. And so that's if I just wanted to ignore them. So I'm just like, let's just drop all the ones that have that missing, or I'm going to take my original data set, I'm going to create it, and I'm going to say, I want to just create it so that I just drop those columns. And those columns I'm not going to use at all in my data science analysis. and we can actually save that as a new CSV, and it's going to save in the same folder. All right, let's go ahead and finish. Let's talk about outlier detection. So remember, outliers are things that are outside of our box plot. So that's all these little dots out here that are past the interquartile range. Now, the way we figure that out, and sometimes we want to throw them out. Sometimes we need to replace them. Sometimes we need to do other things. It's always, again, just like null values. This is kind of you got to make your choice. You have to know the space, because is it really abnormal? So like a house, okay, there's gonna be some outlier houses, but how far is too outlier? So let's just talk about some different things. We can replace it with null values. So we just consider them missing values because they're so abnormal it doesn't make sense. We can replace them with what's called the IQR. So it's, again, essentially I can replace it with a whisker. So I can take these values down here and replace them with a minimum, and these values out here and replace them with a maximum. That's one option. I can also just drop them and say this is really weird. It's going to mess up my whole model and so forth. So again, let's take our missing, our one that we had where we dropped our missing data, the columns. So we dropped the building size and the building year and those sort of things. So we just have now all of this. We brought it together. Let's start looking at, again, some outliers. So I'm going to go through and I'm going to take this. These are all my numeric columns. Now, again, I'm including postal code. Technically, I know postal code is not numeric, but just for the sake of this, it is your. If I ask this, what are numbers, it would look at this and say, okay, postal code's a number. I'm now going to do this one. This one's actually kind of a funny for loop. So it's going to iterate I, and then it's going to take a variable and enumerate numeric columns. So when it numbers them, rooms is going to become 0, distance is going to become 1, and so forth. I'm now going to do a subplot. Essentially, means it's going to have 4 of them in a row. But subplot is off by 1. It starts counting at 1 instead of at 0. So I have to, don't ask. It's one of those weird things. And I say I want to look at the data box plot and tell it the whisker is 1.5. And let's do a tight layout, and we're in title. So we're just looking at these things. This is going to make it nice and secure. And again, can take a second, and you can see that all these outliers. So rooms have all these outliers up here. Distance, all these outliers. Postal code, all these outliers. Again, I really don't care what postal code, but bedrooms. We talked about this. There's even this anomaly down here of 0 bedrooms. It does have that. We have bathrooms, cars, land size, tons of outliers in land size and property count and so forth. So when we look at these, the ones that seem, a couple ones like, again, property count, there could be a lot of reasons why there's land size. That's not really, it might be a weird one. Postal code, again, I really don't care about. So we want to go through and analyze the ones that really care about, which is going to be rooms, distance, bedrooms, bathrooms, cars. Those are things that it may not be realistic in some cases, because we're looking at them. You can kind of think about what's realistic. So up here, for instance, bedrooms, the outlier total rooms is 15. That's a 15, 16. That's huge. Bedrooms 20. I don't know about any of you. I don't know about you. I've never been near a 20 bedroom home. Never heard of it. Never seen it. I actually take it back. I think I heard recently, anyways, about like some NFL player who had a crazy number of bathrooms in their house. And again, this bathroom's like, can you imagine a house that has an 18-car garage, 9 bathrooms, 20 bedroom? That sounds like a really enormous house. There are people maybe who build houses like that, but I really don't know why. Because the other thing is that's possibly just simply someone was counted up an apartment complex as all they went through an apartment, said how many total rooms are there, bedrooms, bathrooms, cars, instead of actually counting the individual units. So that could be the cause of all these things. So while it could be unrealistic, we could actually see things like that. Distance, again, distance really could be in terms of context. I don't know more about Melbourne, so I don't know how far things are out. Postal codes, well, they're just really categorical. Land size, it may seem unrealistic to have a really, really large land size, but remember, you could have a land property that actually is, like a farm. That would really throw it off. Property count, this number of suburbs, and so that number really could be genuine, not really outliers. And price, again, there's a lot of very factors in price, and that one, yeah, let's just talk about it. So in general, here's what I'm going to do. I'm going to do this thing, and this one's kind of interesting. This is going to calculate for each of those columns. It's going to calculate out Q1, Q2, and find the interquartile range of each and every single one of those. So it's actually going to, this right here, in essence, is going to create because numeric columns was a bunch of columns, it's actually going to count this and create essentially another data frame, an array with all those that are at quartile 25% and those at 75%. It then is going to take that, it's going to calculate this, which is going to create a whole new column, and then we'll build this again for each and every single one of those columns. So if I do this, it's essentially going to, this down here is going to give me the percentage of outliers, because this one is essentially how many values are less than the lower whisker. This is OR in Python. I think you know that. And how many values, so how many values are less versus how many over. Count those up. It's going to count up those. So it's going to true or false in each of these situations. It's going to go, okay, let me do an array of true, false, sum. So it's each one's, it's just one or the other, and then divided by the total number. So if we do this real quickly, rooms, very small amount. I mean, 8%. That's really, I mean, well, we'd multiply by 100. So actually, this is a percentage. So this is 0.08%. That's less than, you know, 1/10 of a percent. That's really tiny. However, distance, that's a pretty solid number. Bedrooms is 4% are outlying. Cars are outlying. Prices outlying. So we now have an idea about which ones really are out there. Bathroom, total rooms, not a lot. Don't really worry about that one. So we have all these different things. Now, again, there's lots of different ways to treat these. I'm going to focus on using the whisker method. So I'm going to replace them with the min and max. And the way to do that is we're actually going to create a new function here. This is how I'm going to treat them. And you asked about creating classes. Yeah, you can create classes. You also can create plenty of functions. So I'm going to create a function here where I'm going to input a data frame and input the column or the name of numerical values. So this is going to be a string, and that's the name of the columns. And it's going to output the data frame after it does this change. And so what it's first going to do is going to calculate quartile 1. It's going to calculate quartile 2. And then it's going to calculate the IQR, so the difference of those two values. It's going to calculate the lower whisker and the upper whisker. These are simply stored within the actual calculation. Again, it's not adding them to the data frame. But this is where we add in a new thing called clip. What clip is going to do is it's actually going to come here to the data frame at a specific column. And if the value is, I gave it bounds of lower and upper. So you give it a minimum maximum value. And if you have this, if it's below the lower whisker, it just resets it to the lower whisker. If it's above the upper whisker, it sets it to the upper whisker. So all it does is it's going to take those outliers and pull them in and set them on those ends of the whiskers. So this function, now I have to run it, even though it's not actually evaluating it here, you have to compile it. And now we're going to go ahead and run that. I'm going to take data and I'm going to run it on rooms, just rooms alone. And then I want it to visualize what that looks like with Boxplot. So if I do this, notice all my outliers are gone. And here you can see that the 50 percentile was at 3, come all the way back up here to this one. Rooms, it was about 3, with my max still being up here and still being down here. So it didn't really mess with those values, and it shouldn't have, because the median value, if you pull everything in, it's still the middle value. That's why median's really great. It kind of keeps these things together. Now, I can also simply run this and on all the other values. And so I've now actually done the same thing for bedrooms, cars, bathrooms, and land size. And if I just tell it again, here is a four plot that's again just going to create the same set of box plots like up here. But now because we've treated all these outliers should not show up. And we're only going to do this for our columns, rooms, bedrooms, bathrooms, car, and land size because we already determined postal code. Really don't care about that one. Price, that variance actually could make sense, and distance can also make sense. So we've kind of ignored some of the other ones and just taken these that are like they're possibly outliers. They're really horrible outliers, and we kind of made them look like this. And now we have this, which is more you can kind of see more clearly where medians are and so forth, and how that really corresponds to all these ideas that we have going on here. So I've now treated all this. I do have to come back and change them all into integers. Again, whenever we change columns values, we do want to make sure that they are integers because it is possible that when I did this, remember this calculation was this minus 1.5 the IQR. That could have had a fraction, I mean a decimal, because we could have ended up with 0.5 of something. So I'm just going to make these all integers, and then I'm just going to tell it to create a whole new no outliers CSV. So in my folder where I created all my things, I now have two extra CSVs, one with no outliers and no missing data, and one with no missing data. So we've gone through all this. Let me know what questions you have. And again, go ahead and start working on that project after you play with this a little bit. And I want you to try to work through answering some general analysis using these ideas.